All right, today we're going to start our last section of this chapter, estimating roots. The essential question is, how can I estimate a square root if it's not perfect? So did you know there's a formula, t equals square root of h over 4. This formula can be used to find the time, t, in seconds it will take an object to fall from a certain height in feet. So if I've got an object and it falls to the ground, I can find out how long it took to fall to the ground. Why can I figure this out? Because I know there's a constant. I know about gravity. It pulls at the same force. So let's take a look at an example here. So suppose an apple falls from a branch that's 16 feet exactly from the ground. How long will it take to fall? Well, what I can do here is I know that the apple itself is going to fall 16 feet, so that's your height. I can plug it into my formula. I messed up here, so sorry about that. Square root of 16 over 4, where the square root of 16, that's a perfect square. That's lucky for us because the square root of 16, well, that's 4. So 4 divided by 4 is 1 second. So about 16 feet in 1 second. Now suppose the distance 20 feet. We've got an apple that's a little bit higher. So 20 feet. So I plug this in and I look to this and I say, wait a minute. The square root of 20, well, this is not a perfect square. So that's a little bit of a problem. Square root of 20 is not a perfect square, so we're going to need to estimate. We can get close. We know it's a little bit more than square root of 16, which if we looked at before, square root of 16 turned out to be 4 divided by 4. But I know it's going to be a little bit more than that. Okay, so how much more than that? Well, we're going to try to estimate here. So we know that root 5, this is just a separate example here, square roots, estimating square roots. We know that root 5, if you plug this into your calculator, remember you can just type it in to a basic calculator, 5, and then use the little radical symbol for square root. It tells you it's 2.2360679, and it keeps on going actually. So we know that's not a perfect square. If it was a perfect square, it would have a nice, just an integer, like a 2, just one number. So on the number line, if we take a look at this, square root of 5. All right, so that's in between the integers 2 and 3. We figured this out using a calculator, 2.23. So we know it's between 2 and 3. If I kind of map it out here, square root of 5 is really close to square root of 4, which we know is a perfect square. And the next higher one is square root of 9, which is 3 here. So since root 5 is this decimal, and it's close to 2, and we know that root 5 is close to square root of 4, it's just a little bit to the right of it, but less than root 9, we can estimate that this is really close to 2, so it's approximately 2. It's really close to 2, but not exactly. Okay, so let's take a look at another example. Let's estimate root 51. Well, if I put on a number line, I know that root 51, that's just bigger than root 49, which root 49 I like because that's a perfect square. That's 7. But it's less than the next perfect root, which is root of 64, gives us 8. I know it's somewhere between these two. I know it's really close to 49, and the next higher one is 64. So a couple of things I can pull from this. Root 51 is between root 49 and root 64. Okay, both of those are perfect squares. That's a helpful tip. You'll need to know that later. So root 51 is really, when you figure it out, it's between 7 and 8. Remember, without the square roots, because the square root of 49 is 7, square root of 64 is 8. So we know it's between those. So I'll even show you my calculator, 51, and then the square root of that, it's going to give me 7 point something. There it is, 7.14. Why? Well, because it's just slightly bigger than 7, but less than 8. And there that is. We know that it's closer to 7 than it is to 8. So we can say that it's roughly, approximately 7. It's approximately 7. Now, if you had to really try to give me some decimals, you say, well, I don't know, it's so close to 7, it might be 7.1, 7.2. If it was somewhere over here, it'd be closer like 7.7. Well, that was helpful. Yeah, anyway, sorry about that, Bill. We know that it's, it would be closer to 8, but no, it's not. For instance, over here, if I do like the square root of 60, for instance, 60 is going to be somewhere here. So because it's somewhere here, I know the answer is going to be close to 8, so maybe like 7.6. Let's check it out. Square root of 60. Oops, root. Close, 7.7. So there you go. It's closer to that. Let's try some on your own. Well, with my help, and then you could do some on your own. So estimate to the nearest integer exponent. Root 37. That helps me remember that root 37, Boy, I know that root 36 is a perfect square. And the next one after that would be root 49. So it's really close to this one. So we'd say, look, it's a little bit more than root 36, which is 6. So my answer here is approximately. Make sure you use the approximate symbols. It's approximately 6. If you really wanted to check it out, 37, square root it. There it is. It's really close to 6, 6.08. Let's try another one, 129. All right, so 129. Well, that's really close to 121, a little bit more than that, actually. So since 121 is 11, we can say this is approximately 11. And we check it out here, 129, square root, sure enough, there it is, 11.3. Let's try another one. The square root of 11, here's two more. Square root of 11, that's really just a little bit more than root 9, which is 3, so we could say this is approximately 3. How about this funky one here? 47.9, square root of that. It's a little less than 49, so we could say it's approximately 7. It's going to be a little less than 7, but we get the idea. So same is true for cube roots. So we know our perfect cube roots. A cube root of 10, well, we could say, look, I know the cube root of 8 is 2, so cube root of 10 is going to be a little bit more than 2. So we'd say it's approximately 2. How about 119? Well, let's see, 119. Well, that's close to 125. Cube root of 125 is 5, so we could say this is about 5. Okay, there's a couple more last examples here. Root 26. Boy, that's real close to root 27. So we could say it's approximately 3. Root 3, that's a little more than root 1, cube root of 1. So we could say this is about 1. And again, the last one here, root 68, that's close to cube root of 64. So we could say our answer is approximately 4. We've got last two quick examples. Antonio accidentally dropped his phone from a bridge, 198 feet from the ground. How long will it fall before it meets its disastrous fate and hits the water? So let's approximate. Remember, this is one of our first examples, finding out how long something falls. So, oh no, he dropped his phone. It's dropping. How long will it drop for? Well, we plug it in. However, this is my problem. This is not a perfect square. I have to estimate it. Well, let's see. Square root of 198. Well, 196, square root of 196, 14. So it's pretty much close to 14. A little bit more than 14. So we can estimate it to be about 14 divided by 4, which is 3.5 seconds. So Antonio's going to watch his phone drop for 3.5 seconds before it meets its watery grave. And for the last example, Delilah is designing an art project in the shape of a square. It has an area of 104 square inches. If she wants to put a strip of ribbon around it, how long will each side be? Let's take a look. She's got this image, and I want to know how far that is. Well, if I know the area is 104, that's not a perfect square, but that's really close to 100, and 100 is 10. So we can approximate that this is about 10 inches. Geez, there it is again. She's going to need a little bit more than 10 inches for each side. Sorry about those bells. Okay, I got to go.